Good morning, students. In this session, I want to discuss about Unit 3 Multivariable Calculus. The topic is Total Derivatives. Total derivative definition. Let u equal to f of xy. That means u is a function in terms of xy, where x is phi of t, y is psi of t. That means both xy's are functions of t. Then we can express u as a function of t. U can be expressed as in function of t alone by substituting the values of x and y in f of xy. Then we can define the ordinary derivative du by dt, which is called the total derivative of u. So u is in terms of xy, but xy's are in terms of t. Ultimately, u is a function in terms of t. So which is obtained by just substituting these values, xy values in u. So u becomes the function in terms of t. Then we can define the ordinary derivative du by dt, which is called as the total derivative. The formula for total derivative is given by du by dt is dou u by dou x into dx by dt plus dou u by dou y into dy by dt. So it is the formula for total derivative. Also, the total derivative is given by du is dou f by dou x into dx plus dou f by dou y into dy, because u is in terms of f of xy. U is a function of f of xy. So total derivative formula can also be taken as du as dou f by dou x into dx plus dou f by dou y into dy, which is known as total derivative of u. Differentiation of implicit function. If a function f of xy equal to c is such that x cannot be solved explicitly in terms of y, so x cannot be reduced into the terms of y, then f of xy is equal to c is called implicit function. If f of xy equal to c is a differentiable function of x, then df by dx equal to 0, which is equal to dou f by dou x into dou x by dou x plus dou f by dou y into dou y by dou x, so which is equated to 0. And then simplifying this equation, so we will get the value of dy by dx is minus dou f by dou x upon dou f by dou y, where the denominator function, that is dou f by dou y, cannot be 0. This formula is known as the implicit formula. This formula is known as implicit formula. Very, very, very important. Don't forget, the implicit formula is given by dy by dx equal to minus dou f by dou x whole upon dou f by dou y. No problem. If u is sine inverse of x minus y, where x is 3t, y is 4t cube, then show that du by dt is 3 by root of 1 minus t square. So u is in terms of xy, but here xy's are in terms of t. Now we have to compute dy by dt, which is obtained by using total derivative formula. So given u and xy's, which is defined in u as a composite function of t. U is a composite function of t because u involves xy's, but xy's are involves in terms of t. Ultimately, u is in terms of t. Now we will have the formula du by dt is dou u by dou x into dx by dt plus dou u by dou y into dy by dt, which is already discussed in definition. Now substituting the part derivative values in this equation, so we will get the expression like this. On simplifying, we will get the value, that is a 3 by root of 1 minus t square. It is the required value of du by dt, that is a du by dt is given by 3 by root of 1 minus t square. Problem: if u is x into log of xy, where x cube plus y cube plus 3xy equal to 1, then find du by dx. Solution: given u, we have to compute du by dx. We have the total derivative formula, that is du by dx is dou u by dou x into dx by dx plus dou u by dou y into dy by dx. That is dou u by dou x. Dx by dx value is 1 here. Du by dou u by dou y into dy by dx. So dou u by dou x is obtained by differentiating partially with respect to x. X log x is differentiated using product rule. Log x kept silent, x derivative is 1. Plus x kept silent, log x derivative is 1 by x. Plus log y constant, which is kept silent, x derivative is 1. So it is the value of dou u by dou x. Simplifying, log x get cancelled, 1 plus log y. So dou u by dou y, similarly, we will have x log x derivative is 0 because while differentiating partially with respect to y, we have to keep x as constant. So x log x derivative is 0. X constant log y derivative is 1 by y. That is x into 1 by y is x by y. So it is the value of dou u by dou y. Now we will have x cube plus y cube plus 3xy minus 1 equal to 0. It is the implicit function because x cannot be solved as in terms of y. Now the formula for implicit formula, that is dy by dx is minus dou f by dou x upon dou f by dou y. Substituting the partial derivative values and then simplifying by taking out 3 as a numerator and common as in denominator. So clearly 3 get cancelled. So we will have minus of x square plus y by y square plus x. It is the value of dy by dx. Now substituting all these values, so we will have the derivative du by dx. So it is the required du by dx, which is obtained by using total derivative. Now another sum. If x cube plus 3x square y plus 6x y square plus y cube is 1, then find dy by dx. Given function, implicit function, let it be f of xy. Now computing dou f by dou x, which is obtained by differentiating partially with respect to x, keeping y as constant. X cube derivative 3x square, 3y constant, x square derivative 2x, 3y into 2x is 6xy, plus 6y square, keep it as a silent, x derivative is 1, so 6y square, y cube derivative 0, minus 1 derivative 0. Similarly, differentiating f partially with respect to y, so we will have like this. Now we have implicit formula to find dy by dx, that is minus dou f by dou x upon dou f by dou y. Just dividing these two functions, so we will get answer. So it is the required value of dy by dx. So simple. Just we have to remember this formula and we have to get partial derivatives of f with respect to x and with respect to y. Don't forget, while differentiating partially with respect to x, keep y as constant. While differentiating partially with respect to y, keep x as constant. If the constant term is a separated one, whose derivative becomes 0. If the constant term is multiplying the independent variable term, just take it out the constant term and keep it as silent and then differentiate the independent variable term. Second method, given equation, differentiating ordinary differentiation with respect to x using product rules and single functions can be easily differentiated. Then also we can obtain the value of dy by dx. In both cases we will get the same result. Don't forget, if we know the formula for implicit formula, then very easy to find the ordinary derivative formula, that is implicit formula, ordinary derivative dy by dx. If we take the ordinary differentiation like this, then also we can find the dy by dx. Both are same. Another sum, if x is u square minus v square and y is uv, then find dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y. So here x is u square minus y square, v square and y is uv. Let it be equation 1 and 2 respectively. Differentiating equation 1 partially with respect to x. So x derivative is 1, u square derivative 2u into dou u by dou x minus constant v square derivative 2v into dou v by dou x. Let it be equation number 3. Similarly, differentiating equation 2 partially with respect to x. So we will get y derivative is 0, uv is differentiated using product rule. So v kept silent, u derivative dou u by dou x plus u kept silent, v derivative dou v by dou x. Let it be equation number 4. Now solving equations 3 and 4, we will get dou u by dou x value and dou v by dou x. These are the values. On differentiating 1 and 2 with respect to y, similarly we will get like these equations. On solving 5, 6 equations, we will get dou v by dou y value and dou u by dou y value. Another sum, if u is x cube plus y cube, where x is a cos t and y is b sin t. So u is in terms of xy, but xy's are in terms of t. Ultimately, u is in terms of t, because while substituting xy values in this expression, we will get u in terms of t. Now we have to find out du by dt and verify the result. So du by dt is obtained by using total derivative formula. So we have u, x, y. Now total derivative formula is du by dt is dou u by dou x into dx by dt plus dou u by dou y into dy by dt. Substituting these partial derivatives using these equations, dou u by dou x differentiating u partially with respect to x kept y as constant, x cube derivative 3x square, y cube derivative 0. Now dx by dt differentiating x with respect to t ordinary, a constant cos t derivative minus sin t, that is minus a sin t. So y is also differentiated with respect to t, that is b cos t. Dou u by dou y means differentiating u partially with respect to y, we will get y cube derivative 3y square, x cube derivative 0. So these are the partial derivatives and ordinary derivatives computed using the given equations. So it is the value of du by dt. But here x is a cos t and y is b sin t. Substituting the values in this equation, so we'll get du by dt in terms of t. So let it be equation number 1. Now verification, given equation x u is x cube plus y cube, directly substituting x y is in terms of t. Now we can compute du by dt. So du by dt is obtained by differentiating ordinary differentiation. So a cube is constant, cos cube t derivative 3 cos square t, and then cos t derivative is minus sin t. That is minus a3 a cube cos square t into sin t. B cube constant, sin cube t derivative is 3 sin square t, and then sin t derivative is cos t. So let it be some equation number 2. So clearly equation 1 and equation 2 both are same or different? Same. So clearly the result is verified. Hence results 1 and 2 are same. Thank you.